Quantum tonight. Whatever happened to cold fusion? Hello and welcome to Quantum. Tonight, a special report on one of the most dramatic science stories of the last 10 years. In 1989, scientists Martin Fleischmann and Stanley Pons announced to the world that they had produced fusion, the power of the sun, in a test tube. At first, there was incredulity, then doubt, and finally ridicule, until it seemed that cold fusion was dead. In fact, today it's still very much alive. There's no doubt that the experiment produces energy, and lots of it. But is it fusion? Leading research teams around the world are hard at work trying to solve the riddle. Jerry Thompson from the Canadian CBC network travelled the world to compile this report.
If you're the man who tells the world how to capture the power of the sun in a test tube, and if the world says you're wrong, that's impossible, where do you go to weather the storm?
Let's go and find some cheese.
You might be tempted to find a quiet place
The fromage ici, non?
Du fromage?
Fromage.
where people are friendly and don't care much about the mysteries of chemistry and quantum mechanics. The village of Valbonne, France, not far from Nice, is just such a place. Now, if you remain absolutely convinced you're right, even though a majority of the scientific community doubts your every word, what do? Well, you and your colleague could decide to set up shop in a brand new laboratory and keep right on working as if nothing had happened. And that's exactly what Stanley Pons and Martin Fleischmann have done.
Just the loading.
Flashback 4 years ago to Salt Lake City in the shadow of the Wasatch Mountains, where cold fusion germinated in a test tube. Then, from a hastily called press conference, cold fusion spread like a fever around the world.
Basically, we've established a sustained nuclear fusion reaction by means which are considerably simpler than conventional techniques.
For 30 years, physicists have spent roughly $500 million per year using massively expensive reactors like this, trying to recreate conditions on the surface of the sun to make atoms fuse and release energy. But so far, the reactors have consumed more energy than they've produced.
Early on, we didn't have very much money, so we chose Rubbermaid here, which worked out quite well for the water bath.
Pons and Fleischmann said they could do fusion with a simple tabletop experiment using a car battery in a test tube. Current from the battery flowed through a solution of heavy water in the cell. Deuterium atoms in the water were forced into a metal rod made of palladium. The theory is that palladium has special characteristics which pack the deuterium atoms so tightly together, they fuse and release energy.
Much more energy is coming out than we're putting in.
I think this is something so extraordinary.
Major scientific discovery about nuclear energy.
Inexpensive, plentiful, and clean nuclear energy.
Congratulations.
For a few months, Stanley Pons and Martin Fleischmann were heroes, celebrity scientists.
Kiss his ring, Jack.
But fusion fever faded as quickly as it came. Several laboratories reported successful cold fusion experiments early on, but others found nothing at all. And soon there was a wave of strong negative reaction, primarily from physicists who said there could be no such thing as cold fusion.
I wish it were right. I think all of us here wish it were right. But science is an objective business, and when the wine goes sour, you have to pour it out.
In Washington, a congressional committee was at first enthusiastic and considered diverting $25 million away from hot fusion to cold fusion. But as negative reports came pouring in, the politicians got cold feet and said no to cold fusion. In the press, the tone shifted from adulation to doubt, from derision to ridicule. Pons and Fleischmann had their defenders, but life at the eye of a storm had become intolerable. Martin Fleischmann went home to Southampton in England. Stan Pons took a leave of absence, then resigned from the University of Utah, and finally vanished. Only a handful of people knew where he'd gone, and most of the world assumed cold fusion was dead.
4 years later, cold fusion is far from dead and about as far away as a person could be from Utah. Stan Pons and Martin Fleischmann are alive and well here in the south of France, working in a brand new laboratory with Japanese money.
The Toyota Corporation, through a subsidiary, has provided funding for the next wave of cold fusion experiments.
Well, these particular labs were designed from the bottom up to accommodate types of experiments they were interested in.
Rigid climate control in the lab itself and better equipment allows Stan Pons to control the temperature in these cells to within 1,000th of a degree, the kind of accuracy only money can buy.
Of course, we've been able to put at least an order of magnitude better precision and accuracy on our measurements.
Is there anything now that you know that makes you disbelieve what you originally said?
No, not at all. Not at all. Nothing. I mean, the criticisms that came were 95% of the criticism was just unwarranted. I could almost use the word stupid for most of it. The other 5% was well-founded, and we've certainly had time to go back, take up these points, this 5% of the criticisms, and convince ourselves that we're correct. No problem.
You're still convinced you're correct?
Absolutely. This is totally reproducible. We've done this many times. The first cell starts to boil.
The one on the left is boiling.
The one on the left is now boiling.
They've shot a time-lapse video to document the enormous heat generated by their latest series of cells.
That electrode is at least 300 degrees centigrade now, with very little power input. And now you can see that it gets driven into a very high rate of boiling. Now it's putting out about 170 watts right now.
Fleischmann and Pons say their electrodes generate the same power per cubic centimeter as the fuel rods in a conventional nuclear reactor.
The heat is generated in this, and this is about 140, 150 watts of energy is generated in the system.
From that tiny little piece of palladium?
From that piece of palladium.
So you're putting how much in and getting how much out, roughly?
Well, according to my notes for this particular electrode, it was about between 30 and 40 watts putting in, and the total out of over 170, 180. So the excess was about 140, 150 watts.
So you put 30 watts into that and got 180 watts out of it?
170 under those conditions.
Pons and Fleischmann and about a dozen colleagues are now at work on 5 different versions of their cold fusion cell, redesigning and rebuilding to increase both temperature and pressure as they scale up toward a small fuel cell that would power your home.
This again is another attempt at developing, scaling it up to a technological device.
And something like this could actually provide power for to run a household?
Something on this size could run around 20,000 watts output, continuous.
20,000 watts?
Yeah, 20 kilowatts, which is approximately what you need in a house on a continuous basis.
And it would run for how long?
Well, theoretically, consuming all of the materials and not consuming the palladium, I think Fleischmann's calculation is on the order of 10 to the 50 years, 100,000 years.
100,000 years.
Hopefully. We'll settle for 10 right now.
But the dark mystery of cold fusion won't go away. As Pons and Fleischmann work in the south of France, the critics are as skeptical as ever, convinced that it's all just a grand illusion. Debates about the validity of controversial new science frequently are referred to London and wind up on the desk of this man, John Maddox, a theoretical physicist and editor of Nature magazine, one of the most influential science publications in the world.
I think palladium itself has turned out to be a very interesting material. It has a very strange electronic structure, which no doubt is why it absorbs such a lot of hydrogen. Anything might come out of that.
Having said that, Maddox still thinks cold fusion is nothing more than a mirage.
Well, I think that the idea is dead, at least in the form that Pons and Fleischmann gave it currency. It seems to me a phenomenon that happens from time to time in science, where people think they have a spectacular discovery. They know that it's no longer as certain as they believed, but they hang on to the delusion that they're right. And no, many other instances like that, where people have been trying to make water run uphill for years after the great discovery without any success at all.
Is cold fusion equivalent to trying to make water run uphill?
I think so. I think so.
But if cold fusion is just a crazy idea, then why are hundreds of other scientists still trying to make water run uphill 4 years later? In October 1992, Pons and Fleischmann were only two among several hundred scientists who presented new papers at the 3rd Annual Conference on Cold Fusion in Nagoya, Japan. Scientists from around the world say they've reproduced the cold fusion effect, many of them using techniques completely different from Pons and Fleischmann. Dr. Aichi Yamaguchi, senior scientist with the Nippon Telephone and Telegraph Corporation, soaked sheets of palladium in deuterium, cooking them in a vacuum chamber that triggered the release of excess heat and helium-4, which Yamaguchi believes is positive evidence of a nuclear reaction. Dr. Riko Natoya of Hokkaido University reported excess heat equal to 3 or 4 times the input power. And her cells used nickel electrodes and ordinary light water to generate the excess heat effect. Dr. Michael McCubry, a scientist at Stanford Research International in Menlo Park, California, reported a net gain of up to 50% excess energy in the form of heat. Professor Akito Takahashi, a nuclear engineer at Osaka University, reported 70% excess heat in several experiments. He thinks that what's happening is not a conventional fusion of 2 deuterium atoms. He calls it a very unusual fusion in which 3 or 4 hydrogen nuclei combine. Professor Hideo Ikigami says the term cold fusion was premature. In fact, the Japanese government, which has decided to spend roughly $25 million on this research over the next 4 years, doesn't even use the term cold fusion anymore. In Japan, they call it new hydrogen energy. But in spite of all this, critics in the United States and Britain still insist that whatever's happening in these experiments, it's not fusion.
There is not a single experiment that has claimed to produce the nuclear products that would be required given the process that Fleischmann and Pons claimed that they were reporting on in 1989.
Dr. Frank Close, a theoretical physicist at the Rutherford Appleton Laboratory in Britain, has written a book called Too Hot to Handle that says cold fusion is pathological science.
Originally, the claims were nuclear process, and everybody said, where's all the radiation? It was very quickly clear there was no radiation about. Now, for mainstream scientists, that said, there isn't anything. We were convinced that that was definitive evidence there isn't anything. So then, those who wished to believe still that there was something said, well, maybe there are unknown mechanisms that hide the radiation. Well, I don't believe a word of that, but let's, to be devil's advocate, stay with that for a moment. So the radiation doesn't come out. Something must be left behind, and I invented the name nuclear ash for that. So, if it were the case that nuclear products were found at the level of billions for every watt, and if there are claims of hundreds of watts for tens of minutes, there's many, many billions of nuclear products that should be around. Those amounts are trivial to find for a nuclear scientist. It's like having a thunder flash go off in your face and trying to hear it. I mean, it's that easy. The fact that those things have been looked for and not found are, to me, the evidence that they are not there.
But in Paris, the thunder flash of cold fusion was loud and clear to Professor Jean-Pierre Viget, who feels he can explain the nuclear mystery. Viget is also a theoretical physicist. He's a professor at the University of Paris and editor of another influential science publication called Physics Letters. Viget admits that in the beginning he too doubted the reality of cold fusion. But now he's read the latest reports from other labs and has done the experiment himself.
In the beginning, I didn't believe in it. Well, when I saw the explanation, I say this must be some artifact in the experiment or in the measuring device of Pons and Fleischmann.
So in the beginning, you didn't believe cold?
No, not at all. I didn't believe it because the nuclear ashes were not there.
Well, what changed your mind?
Well, two things. First, the experiment persisted to give excess energy. So unless you want to refuse to look into the telescope, you have to accept that as a fact. And second, the growing evidence in favor of an energy produced by hydrogen or light water. This couldn't be fusion, so there had to be some new type of explanation. The excess energy comes from a different origin at the low energy level. Because now we know that if you shoot very high energy, a few 100,000 ampere in 100 nanoseconds, then you get huge fluxes of neutrons, which do come from fusion reactions.
So if you take a Pons-Fleischmann type of experiment and you shoot the high intensity current into it,
yeah,
then it becomes fusion.
Then it becomes fusion. But there is a few traces of fusion in their experiments, of course, but not enough to explain the excess heat. It's like a two-stage rocket. I mean, there's something deep hidden there, and then when you increase energy input, then you get more and more fusion. That's what the experiment tells. For example, in Belgrade, they had to stop the experiments and put the whole thing into a tank of water because the radiation was becoming fantastic.
Because what happened?
The radiation and the soft rays X-rays were becoming fantastic, very dangerous.
So they did actually ignite a nuclear reaction?
Yes. And the Russians have seen traces of micro-nuclear reactions.
Jean-Pierre Viget believes the Nagoya Conference was a watershed event in the secret life of cold fusion. Nearly 200 papers were published, and fax machines around the world have been humming ever since with reports of excess heat, nuclear byproducts, and unusual reactions. Some call it fusion, others don't. But semantics aside, the data keep piling up. In Moscow, 50 former Soviet nuclear scientists have been wrestling with the apparent contradiction of cold fusion, nuclear ashes that seem to defy nuclear theory.
Well, we found either excessive heat or neutrons or charged particles, gamma emission, X-ray emission. Well, you name it.
Professor Yan Kucherov of the Podolsk Institute in Moscow says it may not fit the accepted definition of fusion, but it is a nuclear reaction.
For us, we also have heat output maybe 100 times more than experimental error. So the amount of heat is too large to make a mistake. You know, if it was 2 times the experimental error or 3 times, it could be speculative. But it is real. I don't doubt it. I doubt it is fusion. It is some kind, as I believe, some kind of nuclear reaction. Whether it is fusion or it is something else, I don't know.
Professor Kucherov thinks it'll take a lot of time and money to find out exactly what is going on in cold fusion. He says there can be no shortcuts, the basic research must be done, and he doubts anyone can produce a commercial device anytime soon.
It would be wrong to suggest that the United States gave up on cold fusion. Instead, it just sort of went underground, but it kept on happening, and at some of the best, most conservative American laboratories, like the Lawrence Livermore Laboratory in California, the Oak Ridge National Laboratory in Tennessee, and at the Los Alamos National Laboratory across the valley here in New Mexico. Cold fusion experiments are still happening there. Not large, officially sanctioned projects, but small individual experiments conducted by scientists who remain so intrigued by what's happening in those little cells that they just can't let it go. And one of those scientists is Dr. Edmund Storms, who's building himself a new house here in the hills above Santa Fe.
Looks like Pons and Fleischmann were absolutely correct. They may have exaggerated the simplicity of the effect, but they certainly did not exaggerate the reality of it. It is a chemical environment, a special environment of matter, a special arrangement of atoms which make up the basis for chemistry. But when those atoms are arranged in particular ways, it's in that environment that the nuclear reaction can be initiated.
So it's a chemically induced nuclear reaction.
Yes.
Now, is this a significant achievement?
Yes. Yes. It's totally novel. The theory, as we knew it before Pons and Fleischmann, would say that this was absolutely impossible.
A lot of people still say that.
That's true, and I would argue that they should, if they wish to take that view, look at the literature and make an honest appraisal rather than just jumping to that conclusion without knowledge of what's going on.
Until his recent semi-retirement, Dr. Storm spent most of his time at Los Alamos working on nuclear power and propulsion systems for spacecraft. Los Alamos, where the American nuclear bombs were developed during and after World War II, is now a center for a wide variety of experimental nuclear research. When Ed Storms heard about cold fusion, he was irresistibly drawn to it. As an expert in metallurgy, he discovered that tiny cracks in the palladium can wreck the experiment by allowing deuterium to leak out. He's produced 20% excess power and tritium, evidence of some kind of nuclear reaction. And he's kept the experiment going even though the U.S. Department of Energy stopped funding it. For nearly 4 years, almost no one was keen to admit they were doing cold fusion. Ironically, the stigma of discredited science went hand in hand with dreams of huge profits. Stanford Research International in California, a prestigious and very conservative laboratory, was hired to do cold fusion for EPRI, the Electric Power Research Institute, a consortium of the world's largest and most image-conscious power companies. 3 years ago, EPRI was not eager to talk about cold fusion and would not allow its scientists to be interviewed. But the combination of strong data and a deadly blast changed EPRI's point of view. Dr. Michael McCubry.
A lot of people put their research behind closed doors in order to protect the proprietary interests that would lead to commercial value.
Mike McCubry is research director for Stanford Research International. His own attitude toward the benefits and risks of cold fusion changed dramatically 15 months ago.
Certainly the accident of 2nd of January 92 caused me to evaluate what the research program was really all about.
On January 2nd, 1992, Mike McCubry and Stan Smedley, the two senior scientists in charge of the project, were seriously injured when a cold fusion cell exploded. Exact cause of the blast remains a mystery. But Andy Riley, a research assistant who was working with the cell when it blew up, was killed, the first casualty of cold fusion.
So you had to go public for safety reasons, if for nothing else.
Yes, and for the sake of our souls, we had to tell people what we knew. So I undertook a trip to Japan to advise the researchers that I knew of there of what we had learned in our investigation of the accident.
Now, the cells at SRI have been redesigned and set up behind 2-inch thick walls of bulletproof glass.
And you've even got it locked.
Whenever a cell is running, the room is sealed and padlocked, so none of the researchers is exposed to any explosive hazard. All the monitoring of data is done by computer and a closed-circuit TV camera.
We observe under reproducible but very difficult to achieve conditions, an excess heat production. That is, we see more heat coming out of our experiments under these special circumstances than known power input, so that you have an energy source which you must account for, which is between 10 and 100 times too large to be accounted for by known chemistry. So we don't make a claim that this effect is nuclear, but we say that it is not consistent with the laws of chemistry that we're aware of.
This is a paradigm shift. This is a shift in the basic way in which we look at the interaction between matter. And it has the potential to do all kinds of marvelous things that we can't even guess at this point.
Although Stan Pons and Martin Fleischmann did not enjoy the scorn and abuse heaped on them by skeptics, they seem now to have put most of that behind them and are working as fast as they can to develop their first small 10-kilowatt cold fusion cell.
Right now we have cells that are running with net outputs of about on the order of, what, 8 or 10 times the input.
So it's just a matter of scaling, redesigning to harness that on a more continuous basis. That's what most of our research is based on now.
And how many years away might you be from developing something like that?
Well, the first prototypes we built now are, need to be redesigned. I would say probably by the end of the year.
Within a year?
Mm.
You're kidding.
No, I think that's attainable.
Well, since that report went to air in Canada last year, the research has been delayed by the Japanese funders who want independent confirmation of Pons and Fleischmann's results. The two scientists now plan to make a public announcement in June. Meanwhile, the scientific jury is still out on cold fusion. And that's Quantum for this week. Next week, we meet the winner of the Australia Prize for 1994, American ecologist Gene Likens. For the last 30 years, he studied just one forest in New Hampshire. His revolutionary work has led to new clean air laws and shown the way for sustainable land management.
I'm not an advocate. I'm not an environmental advocate in that regard. I'm a scientist. I like to think of myself as a professional ecologist.
That's next week on Quantum. I hope you can join us. Until then, good night.
Later tonight on ABC, Attitude goes out on the beat to discover what young Australians and police think about street crime, law enforcement, personal rights and each other. Cop Out, another eye-opening edition of Attitude, tonight at 9:40.